Class 9 students, could you please switch on your video? Okay, I could not see anyone here. At least I would like to see some students so that we can start this class. Yes, thank you so much. Namaste, good afternoon. I hope you all are fine there. Class 9, today are you shocked? Because your science teacher came to teach science, though the routine is for mathematics, right? Madhaswar will join tomorrow, okay? You will take maths class tomorrow. Today I'm taking a science class. Did you get any problem regarding homework? Homework that I assigned to draw graphs, okay, that between distance and time. Obviously, one graph we can plot that shows uniform speed, another, okay, that indicates non-uniform speed. So, how many of you try to solve or draw the graph? Anyway, okay. Yes, thank you. Let me check the number of participants, and then if I see 30, 40, then we can start, okay? So only 22 till now. Just wait for seconds. Till okay date. So what topics we discuss regarding the lesson 4, chapter 4. If you have any confusion or doubt, please you may have questions. You may raise the question, please. So where they have gone? I could see only one student here. Subham. Subham Patak. Only you appear on my screen. Where are others? No idea. What happened? That technology does not support? Class 9, all of you, please, how many of you have joined in this classroom? Listen, the ultimate aim of education is to be a fearless. Okay, not around you, neither हुने हो अनि तिमीले भिडियो अन नगर्नु भनेको त हामीले के बुझ्छौँ भने साइकोलोजीले राइट डराएको भन्ने बुझिन्छ है डोन्ट वरी वी आर नट गोइङ टु आस्क यु द टप क्वेसन्स अर वी आर गोइङ टु किप इन प्रब्लम प्लिज ह्याभ गड्स क्लास 9 पुगिसक्यो नि तिमीहरूले त अनि तिम्रो सब त साहस हुनु पर्यो नि त आफूलाई अरूको अगाडि देखाउनलाई कन्फिडेन्ट खै त अनि अघि मैले शुभम बल्ल यस आई सर जस्तै प्रणव ओके प्रलोन आर्य या समीर सुधा सन्सु खड्का ओहो लङ टाइम नो सी सन्सु ओके आई कुड सी यु आफ्टर लङ टाइम कहाँ थियो अहिलेसम्म तिमी क्लास त लिइरहेछौ नि ओके ल class हामी बिस्तारै सुरु गर्छौँ okay we'll start today's class and today's topic that we are going to read is obviously that second type of graph about velocity and time okay last time we read distance time graph and today we are going to read okay velocity time graph which indicates acceleration of a body okay the nature of graph shows the acceleration produced in the body so what type of oscillation can we observe okay on a moving body either oscillation 0 or uniform oscillation or a non-uniform oscillation or even at last we have negative oscillation and negative oscillation is called retardation okay the graph will show you okay what type of acceleration is produced while our body is moving acquiring some velocity okay at certain interval of time okay let's begin this class okay for that let me share the slide so that you can see on your screen so if you get any okay obstacles like if my voice is not clear is not audible to you or slide is not clear please you can write okay that complaint in the chat so that I can know this topic that's 9 so before we okay get connected to the topic that we are going to read today let's have 1 minute recap about distance time graph yeah so on which axis do we keep a distance on y-axis because distance is dependent variable right on which axis we keep the value of time on x-axis okay and when we have gathered data when we have the data okay multiple data of distance and time okay as we plot then we can get the line that shows different nature so especially when we plot the graph between distance and time okay this graph always indicates the speed of a body right And when we have the line on a graph, after plotting it, okay, as we draw the rectangular box, that means line from the distance, okay, and line from the time, then means line from y-axis and line from x-axis, then easily we can get the value of distance and value of time, and we can calculate the speed of our body. Okay, the first thing that the distance time graph indicates the nature of speed. Speed 0, uniform speed, non-uniform speed. Another is, okay, by the graph also we can easily find the value of speed, okay, at any point, at any, okay, instant of time, like that. Okay, for that we have to draw a line and find the value of distance, okay, and then time. Understood? Okay. Like distance time graph class 9, okay, that we can have the graph of velocity, that displacement time also. Distance time graph shows speed, okay, then next displacement time graph shows velocity, and there can be zero velocity when the line is parallel to x-axis, okay, and when there is the straight line, okay, that you can see the get originate from the origin and going up, that means far away from the axis, even from x-axis and y-axis, straight line, then you can say that okay, we can say uniform velocity, because equal distance displacement travel in equal interval of time. And when we say that is that negative velocity, and when you find the curve line, that we get non-uniform velocity. That means unequal displacement, okay, are travel in equal interval of time. This is extra. The main you have to read are distance time graph. Then next is velocity time graph. Okay, so chapter 2 force we are reading. Okay, till date we have finished up to distance time graph, and today we are going to read velocity time graph. Okay, these are the topics of this lesson. Okay, velocity time graph. See, look at the slide, class 9. Okay, if you manage time, you can read the words also. First of all, let us know what is velocity time graph. Okay, in the same way we can define velocity time graph at the geometrical relationship between the velocity of a body and the time. Okay, what is velocity time graph? The answer we can give: velocity time graph is the geometrical relationship, okay, between the velocity of a body and the time. That means when we plot a graph, okay, taking the data of velocity and the respective time, at the time we obtain graph, and that graph is simply called velocity time graph, right? And just like velocity, so we can keep, okay, its value on y-axis, or we have to, okay, we have to mention the value of velocity on y-axis and time on x-axis, since time is independent variable and velocity is dependent variable. Okay, velocity may depend on time, but time does not depend on velocity, okay, because time itself keeps on changing. So on x-axis we keep the number of time, okay, value of time. On y-axis we keep the velocity. So when we have many data, okay, that is being gathered by recording or collecting the velocity at certain interval of time, and as we plot those data, then we can get the lines like this, and this line is the graph between velocity and time. Very simple, please. Class 9, please, no need to panic, okay, because both distance time graph and velocity time graph are the line graphs, and to draw line graph for the students of class 9 is the easiest job. Okay, once you get data, okay, if you have to draw the line graph by plotting the data, okay, on the graph, that is very easy. And when you have value of velocity and time, obviously by its name it is clear, it is velocity time, okay, and velocity time is relation between velocity and time. But the thing that we have to understand and get from this graph is what? Acceleration. Okay, the graph is between velocity and time, but by observing the graph, what do you need to understand is about the oscillation of a moving body. So which type of oscillations is that body, okay, acquiring or gaining? We have to define that. Is the body in uniform oscillations, okay, or constant, that is a velocity means zero oscillation, or retardations? The nature we have to understand, and we have to analyze the nature of graph once we obtain the graph. Okay, yes, please. Okay, somebody has written.
Excuse me, sir.
Please, please, please,
Sir,
please.
what is that area under plot gives displacement?
Yes, 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 yes. When you have the line, just below that line, okay, you can have different area. Just like on this slide, you can see the blue color line. Now the slide shown on your screen shows the area, blue color area, okay? And that area can simply show the, okay, that is, let's say velocity between A and B, or the time between, okay, that is A and B, or let's say 6 to 12, like that. That means if you want to calculate acceleration or velocity at any point, okay, then you can find the specific area below the line, and then you can get its value. Okay, here in this slide, the figure shows or the graph shows, okay, AB, or let's say from B, okay, it has constant velocity. But if you really want to know, okay, the time between A and B, then the area can show it. See, at A the time is 6, okay, 6 seconds, and at B the time is 12. So from A to B, okay, how much time is taken? You can simply say 12 minus 6 is 6 seconds, like that. Understood? So when we have number of lines, by drawing the area, by finding the area below the lines, and then we can find respective velocity, time, and even oscillations, like that.
Yes, sir.
Right there? Okay, yes. See here, the first type of, okay, velocity time graph. Now, in case of velocity time graph, there are four types of graph. Okay, four types of plotting we can obtain. The first type is constant velocity. Okay, when we see the line, straight line, okay, that is, sorry, that is parallel to the x-axis, straight line parallel to x-axis. Okay, this one here, and this line obtained by plotting the velocity and time graph, okay, shows that the body is moving in a uniform velocity. Suppose initially, if the velocity was 40 meter per second, even after 12 seconds, the velocity is same, that is 40 meter per second. The body is in motion, but the velocity does not change. The straight line, okay, in the graph of velocity and time, parallel to x-axis, okay, parallel to x-axis, always shows the body is in constant velocity, means the oscillation is zero. Because class 9, the slope of line parallel to x-axis is always zero. Please listen carefully. Here I have added one word, slope. Okay. So in case of that velocity time graph, okay, when we see or get the line, by finding the slope of that line, we can find the acceleration. And the slope of this straight line parallel to x-axis is obviously zero. That means zero oscillations. Okay, next time, okay, when I bring questions and if I show the graph like this between velocity and time, okay, the students of class 9 must be able to say that the body is in constant velocity, its velocity does not change, and even the oscillations of a body is zero, because oscillation is change in velocity. If the velocity does not change, then how can it have acceleration? Okay, this type of, okay, graph, first type of graph between velocity and time. And let's see another second graph. See, okay, the graph shows, or let's say the line in the graph clearly shows, okay, increase on x-axis means time is increasing, okay, but the velocity is decreasing. And when the velocity of a moving body decreases, the final velocity becomes less than the initial velocity. And when we have V is smaller than U, V is final velocity, U is initial velocity. When we have V is smaller than U, obviously oscillation will be negative, and the negative oscillation is called retardation. As you are shown, the graph obtained between the velocity and time, the line, okay, shown in this nature is showing that velocity changes. But how is the change of velocity? Decreasing. And when the velocity decreases, it always gains negative acceleration. Please look at the nature of line carefully. So how is it drawn? Okay, opposite to this positive oscillations I will show, then you will easily find the difference between the line of negative oscillations and positive oscillations. Okay, here at last, this one, okay, here at last, you can see this wind, okay, velocity is so less, see, but the time is more. Yes, time changes, but the velocity changes. How it changes? The value decreases, velocity decreases, isn't it? And so this line easily shows, indicates that the body is having negative acceleration. Understood? Okay. Now let's see another type of graph, like this curve line. Okay, in distance time graph also, when we obtain curve line, we easily say that the body is in non-uniform speed. Similarly, when we obtain curve line that makes a parabola between velocity and time, okay, it also shows the body is in non-uniform acceleration. There is not the equal rate of change of velocity. Sometimes velocity is 2 meters per second, sometimes 6, or sometimes even 3. Okay, so randomly, when the velocity changes of a moving body, and it always has non-uniform oscillations, the graph like this, okay, the curve line obtained between velocity and time, okay, shows the body is non-uniform oscillations. There is change in velocity, but sometimes decrease and sometimes increase. Okay, three types of, okay, and the same, I'm repeating, the straight line that is parallel to x-axis, it also shows no oscillation, oscillation 0, velocity not changing. Okay, one more. Oh, one more I have to show to you. Three types of graph between velocity and time. Okay, you have already seen on your screen. The fourth type is positive acceleration. Okay, if you see this graph, so you can see here, okay, at the terminal part, at the end part, okay, the velocity also increases with the increase in time. And when the velocity increases with the increase in time, the final velocity v always becomes more than the initial velocity. And we know the formula to find acceleration is a equal v minus u upon t. When the value of v is more than the value of u, then obviously oscillation will be positive. Okay, the graph. So there was technical problem. Yeah, load shedding. Okay, on my home. So I luckily I again could get chance to join. Yeah. You're right. They're also same. Yes, Suvedi. So there was load shedding in my home. Okay, let's talk. Okay, about the topic for 5 minutes. Then we'll conclude for today's okay discussion. We were saying the types of velocity time graph, and for you it's very easy. Any confusion, any doubt? Okay, let me say more. Class 9. So let me open the document about the slides we already discussed. We were here, I think. Yes, positive oscillations, four types of okay velocity time graph. Already we saw. Okay, one more time I'm going to repeat. This shows negative oscillations. Yeah. Here. Okay, the first line. What does it show? You know, first line obviously it is negative oscillation, right? And the second line. Okay, second line from here to here, it shows positive acceleration. Okay, let's try to study the nature of graph that we have obtained from okay the graph between velocity and time. And if I say okay from this point to this point, this line again says the negative acceleration, and from this point to this point again it is positive acceleration. So when you see the peak going upward, the line shows positive acceleration, and when you see that going depression, right, downward, and it is okay negative acceleration. It is negative, and these two can be positive. Okay, these are positive, which are uniform. Okay, accelerations, uniform accelerations, positive, and then negative. Clear? Uh, okay. So from this topic, velocity and time graph class 9, you will be asked the question like this. Yes, please. Question like this. Can you see on your screen? Yeah, one photo of graph you can see, and at the side there are some questions given. The first one is name the acceleration represented by OA, OB, and BC. Okay, class 9 mostly. So you will be given the figure of graph, right? And this is the diagrammatic question. And by studying the graph between velocity and time, and you have to answer according to the question. Now, for example, the first question here is name the acceleration represented by OA. Can you see the line OA? Yes, this line OA. Okay, here from O to A OA. And what type of acceleration does this line show? And you can give the answer. Yes, positive acceleration or simply acceleration. Okay, acceleration itself is positive acceleration or positive acceleration. And AB, the next line is AB. What type of acceleration does it show? The AB line is parallel to the x-axis. Yes, yes. Answer, please.
Constant uniform.
Constant velocity and acceleration is zero.
Zero.
Yes. Oscillation. Very good, Sumam. Yes, yes, yeah. Yeah, zero oscillation. Right. Good. Now you are clear. Okay. And the next line is there, BC. The initial point is B. Okay. And C, the final point. The direction is from B to C. Yes, retardation. Excellent. Good. Yes, retardation. Yes, BC indicates negative oscillations. Okay. The first question, okay, is very easy for all students. All can give answer now. See that going up, the line is positive acceleration. Parallel to x-axis is zero acceleration, and then line going down. Okay, that shows the decrease in velocity. It is what negative accelerations, which is called retardation. Okay, that is minus a, or also called deceleration. 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 Now, second question, please. Okay, you have to calculate the oscillation. Oscillation in line OA, oscillation in AB and AC. Okay, and see here O, at O is origin. What could be the velocity here? Class 9, what could be the velocity here? Obviously zero, right? Yes, yes, zero velocity. Good. Then what could be the velocity at point A?
6.
A, what? Yes, 6. Very good. And it is going from O to A. So O is initial velocity and A is final velocity. So final velocity is 6. And then initial velocity is 0. Okay. And then time is how much? So 0 to 2. Okay. Going from O to A, how much time is taken? 2. So 2. So oscillations, okay, that line OA is showing how much? Yeah, 3 meter per second square. Got it? Okay, O initial velocity 0, A final velocity that is 6, and the time taken from O to A is 2. You can see, okay, on x-axis. Then B minus U upon T is A. So B minus means 6 minus 0 upon 2 is 3 meter per second square. So numerically, we can calculate like this. Another method is for finding the slope. Okay, if you assume this AOD is triangle, okay, AOD is triangle. Suppose this angle AOD is theta, and the angle made okay by AO is on axis is acute angle. Obviously, slope will be positive. And if you take angle tan theta, tan means what? Class 9 perpendicular upon base, P upon B. Okay, P upon B, and for this figure triangle AOD, this AD is P and the OD is B, and just find the magnitude of AD. It is from 0 to 6. Okay, so means P is how much? 6. Perpendicular is 6. And find the value of base B from O to D. It is how much? 2. So 6 upon 2. And 6 upon 2 is that is 3. See, by the formula we can find acceleration, and even by the slope, okay, of the line. So we can easily find the oscillation, because slope of the line in the graph between velocity and time is acceleration. Understand? Okay, carefully please listen, class 9. Slope of the line, okay, that is between the velocity and time graph is always acceleration. So slope of OA, slope of OA is oscillations on OA. And how we found? Okay, that is, y2 minus y1 upon x2 minus x1. For here, y2 minus y1 is P perpendicular. Okay, this is y2, this is D here y1. D is 0 and A is 6. 6 minus 0 is 6. And upon x2 minus x1, x2 is 2, x1 is 0, and 2 minus 0 is 2. Okay, 6 by 2, and upon 3. So tan theta, and tan theta is 3 means what? Tan theta is m. M means slope, and here m is slope is A. So oscillations of OA is 3 meter per second square. So we have used two methods to calculate oscillations of OA. Let's try to understand. Now oscillations of AB directly, there is no need to calculate. Calculations. Okay, that A, how much velocity? Suppose this is initial velocity. It is 6 meter per second. And B, this is final velocity. It is also 6 meter per second. So 6 minus 6 time, how much? From 2 to 5. Okay, at A time is 2 and it is 5. From 2 to 5 it is 5 minus 2 is 3. 6 minus 6 is 0. 0 upon 3 is 0. So by using formula, we calculate the oscillations on line AB. Oscillations 0. Okay, but in the graph, directly we can say, because we have justification, we have reason, you can easily write oscillation on AB is 0. Oscillations on AB is 0. Why? Reason is what? Because slope of AB is 0. So slope of line on velocity and time graph is oscillation. So slope of AB is 0. Because why slope of AB is 0? Because this is parallel to the x-axis. It does not make any, okay, that angle like that. So it is parallel to the x-axis. So slope of AB is 0, means oscillation is also 0. Now see here, okay, that is BC from B to C, and C is final velocity B, right? B initial velocity U. You have formula B minus U upon T, right? B is how much here? Okay, on x-axis. On x-axis, Y is always 0. And on Y we have velocity. Means C is on Y x-axis means B is 0. Final velocity 0. 0 minus U is how much? B 6 upon, and time is from 5 to 8. 5 to 8. 8 minus 5 is 3. Okay, minus 6 upon 3 is, it is minus 2 meter per second square. See, so numerically you get oscillations from B to C is negative 2 meter, okay, per second square. So we calculate the oscillation of BC by using formula. And what's about slope? Okay, slope is obtuse. So when we have the line, okay, the slope is obtuse, it is always minus, right? Minus. The same, it is the how much there? P6. Yeah, Subham, directly we can show. Okay, for making you understand only that I'm using formula. And from next time when you are given the question like it, directly we can use slope and find the oscillation. Okay, no need to use formula A equal B minus U upon T. This is the importance of graph. Okay, and when we have slope like this is minus P by B. Okay, and this is B means here. Okay, B is this, and minus P, how much? 6. Okay, it is minus 6 upon and 3, and here we get minus 2 meter per second square. As you get the line like this, that makes acute angle, slope is positive, and as you get the line like this, slope is negative. And see, it is minus 2 meter per second square. Understood, class 9? So you will get the question like this in the exam. Okay, and then you have to give the answer like this. And today I will give the same homework, okay, with different value. And today for this, okay, this much for today. Let me come back. Bujin sir, class 9. Sudha, did you understand to calculate oscillation by looking the graph of velocity and time? Yes, Swimta, did you understand today's topic? How many types
Yes,
of
sir.
velocity time graph? How many types of velocity time graph?
4.
Four. Yes, yes, four. One for positive, another for negative, another for zero, another for non-uniform. Okay, non-uniform. Positive, negative, zero, and non-uniform. Four types. And at last, we try to solve the questions of three: positive, zero, and negative, and the slope source. Any doubt? Okay.
No,
Shivam,
sir.
did you? Okay. Arya, what's about you? Bucho Nani?
Sir, I didn't get that slope. How to calculate by slope?
Yeah. Slope is m equal to tan theta, and trigonometric ratio tan is equal P by B, right? Perpendicular
Yes.
upon base, and in the graph, perpendicular is velocity, and the base is time. Okay,
Okay.
that means what? Velocity of time is oscillation. Now understood?
Yes.
Okay. Sansu, के छ? I could hardly see only one, two, three, okay, four, five, six students. Thank you very much for showing your face to me. Others, I don't know where are they. So many chats there were. Let me read, okay? Okay, we should not calculate. I think Zoom, yeah. That is our problem. केही छ त क्लासमा आजलाई ल आज हामीले भेलोसिटी टाइम ग्राफ पढ्यौँ होमवर्क चाहिँ एक्चुली है गर प्लिज होमवर्क चाहिँ गर रेकर्ड हुन्छ होमवर्क चाहिँ गर हुन्छ ल आजलाई बाई बाई भनौँ त क्लास 9 क्यान वी से बाई बाई फर टुडे एनी केही छ क्वेसनहरू ओ इट्स ओके थ्याङ्क यू यस ओके प्रणव नो प्रब्लम ओके yes but the main that objective is that whether you have understood or not, whether you are learning or not. Thank you Gare, thank you Anushka, Sansu, Subham, Arya. Okay, thank you very much Pralun, Sudha and Subimta. Okay, and thank you all of you. Okay, next time we'll discuss another topic. Thank you, bye bye.